my name's Kimberley Cook. I'm a software engineer at Hive. I'm not actually based in this office. This is the first time I've ever been here. This is just all as new to me as it is to you. So yeah, I'm a software engineer at Hive. I also run an event called CodeBar. I don't know if any of you know, but we run free workshops for underrepresented people in tech. So when Anna first mentioned to me about doing a talk here, my initial thought was, hell no. And that's not because I don't like doing talks, because I actually do quite a few, but it's because I'm terrible at putting slides together, and it's the part that I hate the most, which I've actually paid someone to put these slides together for me. I have a designer friend, and I basically put together what I want on the slides with pictures, and then I sent it to her this morning at 9:30, and I was like, please make it not look shit. And I think she did. She did a pretty good job. So when I was trying to think of what talk to do, I was like, what is interesting, and what's something that I've not really heard before? And then I thought, I work somewhere with hardware, and I don't think I've ever seen a React and hardware talk. And I thought, you're going to be in a room surrounded by devices, so what better place to do a talk? However, I then learned that you're not going to be in that office, and you're not going to be surrounded by devices. So I thought, I'll show you some pictures instead. So this is normally what you'd see. You would see bookshelves covered in bulbs, thermostats, boiler modules. You'll see a QA area with, again, hundreds of thermostats, boiler modules, bulbs, all of the devices that we have. You'll see more bulbs, and I love this little sign that says, do not touch under test. And the new leak sensors, which was actually a picture I got from our Leicester office, and they're all connected to pipes, detecting the water flow. So that's what that's what I was hoping you would be surrounded by, but you're not, so I just thought I'll show some pictures instead. So, what do Hive do? We're predominantly known for our thermostats, of which we have 4. We have our SLT1, which is our first one, which was launched 5 years ago. We have our second one, which was then, you had a boiler module along with it. There was now the third version. This is now the current one that you would get in Europe. So we're in the UK, Italy, France. And then there's also the 4th version, which is the North America thermostat. And that's slightly different because it actually controls your aircon, whereas the Europe one doesn't. And there's a few other wires you can connect to the back. So those 2 bottom ones are our most recent ones if you were to buy a Hive thermostat. But we also have motion sensors, contact sensors, our hub, a plug, numerous lights, a camera, and a leak sensor. So hint why this talk is called Controlling Your Home, because we have so many devices. And the best thing about a lot of these is we launched a new feature called Actions, which means that you can link up the devices and tell one thing to do another one based on another device. So you could say, this one at the top middle is the contact sensor, so you could have that in your front room, and you could say when contact sensor 1, or living room you may call it, is open, turn on light, living room. So you can start pairing the devices together to then have your connected home, which is why our other name is called Connected Homes. So how the hell do all of these work? I'm going to have to look at this slide because I can't point up there. Actually, no, I might be able to. So you'll have a person, and they can either use their Alexa, their mobile, or their desktop. They're all connected to your Wi-Fi. It's not a very good diagram, but I hope you can kind of see. Which is internet, which is Beekeeper, which is our API that we talk to. We have our Amazon Echo Cloud, which when a lights on, let's say, is triggered, it will call these Lambda functions, which will then talk to Beekeeper, which talks to our hub, which is this thing, which then we use a service called Zigbee, which then talks directly to the devices. So in this example, I've got the light and the thermostat. I actually didn't do this diagram, and my friend, she was like, can I please redo it? And I was like, no, because you're £30 an hour, and I use this from work, so no. So here is the time for a demo, which I'm going to do a demo. It's not like a tech it's not a tech demo, it's basically a don't look, my phone is actually open. Let's see, open up. Oh, QuickTime crashed. QuickTime is what I'm using, so there's the thing. So yeah, don't do demos. But basically, you can see this light, and I have the app. Oh, that's so annoying. And basically, I can turn on the light. I can change the color. Yay. I can make it white. I can make it white. I can make it white. So basically, oh, let's turn it off. Cool. So basically, the rest of this talk is going to be about what happens code-wise from the moment I press a button in our app to the moment the device changes. So this is essentially our flow. We have our component, we have our Redux code, we have our sagas, which talks to our API code, and then not in the browser, we have our beekeeper, which is our API that we talk to. We have Honeycomb, which is our platform. Beekeeper is a wrapper around Honeycomb. It just makes it a lot more readable for us. And then we have the device. So let's start. Oh, I realised I have a clicker. Let's start with the components. So generally at Hive, we try to keep all of our component structures the same. So you'll have, this is the bulb example because I'm using the bulb. We have our test folder, which we use snapshot testing at Hive. We then have our styles.js, which is all of our styled components we use. You'll have the intl file, which is all our internationalization strings. You'll have component.js, which is our visual JSX code. And then we have our index.js, which injects our component with actions and selectors from our Redux code. So this, now I'm going to go through what each of the files do. So this is our component.js, and it was that little bulb you would have seen in the demo, but the demo didn't work. Now originally this component would have it takes 21 props in order for it to work, but today I'm just going to focus on the change color one because that's what we've done in the demo. And all this function does is takes a HSV value. Actually, I'm not going to use the clicker, it's not working. So then we have our index.js. This dispatches a Redux action. Now, if you were to run this code, it would be bad. Because what would happen is every time you moved this tiny little dot, thousands and thousands of the requests would get made. And you don't want that to happen for numerous reasons. One, because if you've got crappy internet, all of the requests would get sent at different times, and then Beekeeper wouldn't know what one is the final result, and now that's called a race condition. And secondly, because of all of those requests being made, it would make that interaction really, really laggy. You would have seen that in the demo, but you didn't. So this does move. So one way we can solve this is we can wrap it in a debounce function. Now I actually know this isn't technically right, but actually trying to strip out some of the immutable JS stuff that we have was really hard, so you'll kind of get it. And basically now what this does, it will only dispatch this change color action 1,000 milliseconds after the user has stopped interacting with it. So that's how we can solve that problem. So now, let's talk about the Redux. This now all comes from our state level logic, and we don't keep that in our component folder, we keep that separate. We keep it in a folder called core state, and that's because we persuaded the company to let us redo their native apps in React Native. And so we extracted all of the state level logic in our web app, put it into core, and now we use that across our web app, which is just the React one, and our React Native. It's pretty exciting for us. And so then here, And that state folder, is split up into features. So here you can see we've got the products folder, and then inside there we've got bulbs, camera, contact sensors, heating hot water, leak, motion sense, blah, blah. And then inside those, so now let's go through each of these files, and I'll tell you through what each of these do. So inside of our actions.js, this defines the action that will get dispatched in Redux for that particular feature. Now we use something called create action. That's because it's a shortcut for creating basic Redux actions. And then the string, which is just this color change, comes from our constants file, which looks like this. I put in another example just so you could see. The reason we do keep these separate is because these strings are then also used in our reducers and our sagas. And also I personally also like it when you just open up a folder and you just know you know what to expect in each of those files. We then have our reducer. Now I'm not going to go into too much depth, which is why I kind of tried to grey this out, and I also hate slides with loads of code as well. But basically all this is doing is getting the ID type and then merging in the new value, the new HSV value. But what you also can change bits of the Redux store, and this one here, what it will do is it will set is saving to true. And now what will happen is you want to indicate to the user that something is happening because if you move that. And so there's this little video here, which I'm glad I now actually did do a video, because there you go. So what will happen is when you move it, you'll see this little pulsing, and then that just indicates to the user that it's just saving. And then we use Redux sagas to manage our async code. Sagas watch our Redux store for certain actions and trigger async code, such as network requests. Now what you can also do is you can sync the sagas together for more complex behavior. This watcher here is looking out for this string call, and then it will trigger this change color bulb saga. So this one here. And then this saga, again, I've grayed out code, but basically it's getting the product type ID, it's creating a patch containing the new data for that product. So in this case, it's the new HSV value, makes the API call. If there is an error, it will revert to the original bulb data, because you don't want to save that. It will just show an alert, so it will just say to the user, hey, something has gone wrong. If it is successful, it will then trigger this bulb saved saga, which will then save the new data. So how do we make our API calls? We have a function called handle API. This interacts with beekeeper, which is what I was saying is our API. This handles all of the actions, authentication, passing the response, handling retries, and making network requests. So actually, you'll be able to see in this example, after you see makes an API call, you can see handle API. But let's go back. So then we have beekeeper. Beekeeper is our team's interface with the Hive infrastructure. It's a wrapper around Honeycomb that provides authentication and data in a format that is readable for our JavaScript project. Honeycomb is a low-level verbose API, so therefore for us, we don't really want to use that, so therefore that's why we have Beekeeper. And Beekeeper runs on AWS Lambda, and we use the serverless framework for our deployments. If you want to speak about serverless, you can speak with Anna. Now, just to end, there's a few things. So before I actually started working at Hive, I hadn't really done much hardware work before. So I did just want to end with 5 things I've learned from a year and a half of working with hardware. Feature flag system. Now, because we have so many devices, we're in so many countries, we need a really, really robust feature flag system. And we want to enable feature flags, but the people may not have the hardware yet. So, hardware problems. Now, problem with hardware is if it's broke, it's broke. Like you can't do another redeployment. Like if someone's thermostat is broke, the only way to fix that is to potentially send them another one. We had an issue recently with one of our thermostats where it was broke, And so we had to send out new ones, and then we had to write a custom upgrade system for those thermostats, because, yeah, when it's broke, it's broke. You need a really, really strong QA team. Our QA team is almost the same number of developers that we have. There are some things you just can't fake. You know, you need QA teams to be putting you in certain situations. You know, I need an Italian user with, you know, a thermostat and a plug, or, you know, but please disable leak sensor, you know, like, and that's what they do. They'll give me certain users in certain environments. When I was doing the thermostat upgrade system, it wasn't a feature that I knew I was aware I would be working on, and I went to Canada for 4 months. They let me work remote. And now normally at Hive, if you work, you do get all of the products so that you can work on them at home, so that if you know need to do an upgrade system, you know, you would have all that. But I don't, because I work and travel, and that would be like a suitcase in itself. And I was ringing her every morning being like, okay, remove the thermostats, okay, is the hub in pairing mode? Yes. And I spent like 4 hours with my QA, like having to run through this upgrade process. So if you're working with hardware, you need a really, really strong QA team. Pairing channel. Now what I mean by pairing channel is, in our office, if you put a hub in pairing mode, it will look for all of the devices that aren't already connected to a hub. Now, if you've got an office with thousands and thousands of devices, you don't want that to happen. And there is a bit of a joke around, don't press the install device button on any of the apps. And so the QA team have something called a pairing channel. So as if they want to do that upgrade process or installation process of a device, they go into the queue of the pairing channel, and then they can do that process. And to end, testing. It's a bit like the QA, but sometimes when you're working with hardware, you can't fake something. So sometimes the best thing to do is just do the thing that you need to do. And on that, I found this conversation in our Slack. I think we probably could have faked that, but it's a lot more fun. But yeah, and when I was actually looking for this, I know there was an instant where with the thermostat, I was like, oh, I'd asked my QA, and they were like, oh, you'll have to wait 10 minutes, the thermostat is in the fridge. And yeah, sometimes you just have to do the thing that you're doing when you're working with hardware. So yeah, thank you.